Good morning, everyone. So once again, we are meeting in the second day of virtual lab training. Good morning, Mr. Sanish, and good morning, Dr.
Very good morning.
Good morning.
Yeah. Good morning. Good morning. Now I think we've had yesterday we've had a very productive day with a huge participation, and I'm sure our participant would have explored their homework assignment given towards the end of the training program, and they have also enjoyed the first day. Without further ado, unless Dr. Manas is having any quick announcements for our participants, we can start the day 2.
Great. Thank you very much, Mr. Ashmin, and thanks, Shanish. And I welcome all the 89, 90, it's increasing subsequently, the participants, and I wish all the best, and hope you will enjoy, and need to also practice continually, followed by this workshop, as well as please raise your queries and questions on chat box. So Mr. Rashmin will be happy to take up these questions for discussion. I would like to also request Sanish can give some in between some 2 to 3 minutes, 4 minutes, or 5 minutes buffer, so that we can take a few questions, if any, or even if participants can also use virtual hand raising, so I can able to allow them to ask the questions in appropriate time. When Rashmin will knock me, then I will allow the person whose name he will pick up, and they can ask the questions directly to our resource person and our team. So with these words, thank you very much, and over to Rashmin to continue.
Good. And I have 2 quick notes. Number 1, as mentioned yesterday, we will continue to sort of conduct the training in English, but as we mentioned, you are more than welcome to raise any of your questions in any of the local languages that you are familiar with. So that's number 1. And number 2, and we've had shared an attendance sheet or a registration form yesterday, and out of 400 we had only 250 participants fill that. I'm not quite sure how many of you have failed to do so, but I would very much like to encourage you to fill the application form. So towards the end of the day, we will be able to share the form with SEMCA and also with the Ministry of Education. And also, let me take this opportunity to once again to extend our gratitude on behalf of SEMCA and on behalf of all the team involved in organizing this training workshop, to our wonderful staff members and directors from the Ministry of Education, who constantly supported us in terms of creating awareness about this workshop, particularly among the teachers and the teacher trainers. So let me repeat that. Thank you so very much, our directors from the Ministry of Education. With that note, I'm inviting Mr. Sanish to continue the session. Shanish.
All right. So thank you, Dr. Rashmi and Dr. Manas. So I just once again express my gratitude to the Ministry of Education and directors and SEMCA, all the higher authorities, for providing this opportunity. So also I welcome all the participants, HODs and trainers from Sri Lankan universities. So I hope you have enjoyed the day one workshop and you get a chance to explore more experiment from this platform. So with that, if you have any queries or anything that you require clarification regarding any of the experiments, feel free to interact with me at the end of the sessions. And during my presentation, if you find any difficulties to hear voice or screen, please inform our organizers, or directly you can type in the chat, etc. So we can make it more clear way. All right. So without any ado, today's session, I'll just give you an overview. I will give you an introduction about significant findings, like research findings, how this is impacting on learning. And we will go through the demonstration of some other experiment. So from the feedback, I have seen that there are several requests for chemistry related titration experiments and biology, etc. So I will cover those experiments as well as some computer science lab, because in our participant, we do have IT and computer science related faculty members are there. All right. So I'll just sharing my screen. So Dr. Manas, could you enable me to share the screen? Yeah, thank you. All right. So I hope all of you can see the screen. Dr. Manas, can you see the screen?
Yes.
Yes, yes.
Thank you. All right. So once again, welcome to the second day of Virtual Lab online workshops. So we are going through some of the significant research findings that we have conducted as part of this Virtual Lab project. Okay. So as I mentioned, that all the descriptions are available in the publication tab, and we can explore from the tab. So I'll just directly go to some of the significant research findings that we have identified as part of the research. So first one is the experimental self-efficacy. The paper title is Virtual Experimental Platform in Chemistry Laboratory Education and its Impact on Experimental Self-Efficacy. So experimental self-efficacy means that fear for completing the experimentation or doing certain activities. So we studied how this virtual lab helped to reduce their fear for performing the experiments, as well as how to increase their self-efficacy to effectively perform the laboratory experimentation. So for that, we have 4 categories. So first one is the conceptual understanding. So we identified that self-efficacy is reduced because of the complexity of the concept that involved in the laboratory session. And second thing is the procedural complexity, which means a certain experiment, there are a lot of procedures students have to follow. So because of this number of procedures, students have a fear for performing the experiments. Their confidence will be reduced or decreased because of the too much complexity in the procedure. So whether it is this procedural complexity affect their self-efficacy or not. And third category is the laboratory hazard. So due to the fact that in chemistry, especially in chemistry laboratory, there are certain equipments, chemicals are hazardous. So this, because of that, their self-efficacy is reduced or not, that we have analyzed. And fourth one is the sufficiency of resources. So as you know that in chemistry laboratory that resources are or chemicals are very limited. So due to that fact, whether that insufficiency of resources will contribute their self-efficacy or not. So directly go to the result session. So the result representing, usually we are conducting the research study like using the control group and experimental group. So control group representing the students, those who are using the textbook or classroom situation to understand the concept behind the experimentation. And experimental group, they are using this virtual lab platform to understand the concept, and they are performing the experiment using the virtual lab. Okay. So here we have a ESC representing experimental self-efficacy test that we have created for analyzing the student's self-efficacy. So there is a pre and post test we have conducted before and after the lab or classroom lectures. So that if you are comparing with the pre and post analysis, as you can see, there is a significant difference between pre and post test. But in the control group, you can see the variance that overlapping with our pre-test result. So which representing there are still students, they have low self-efficacy to perform the experiment, even after referring the textbook or classroom situation, teachers. Okay. So if you're comparing with the experimental group, that you can see the factor 1 in the second quadrant, you can see the experimental group. So that significant difference between these two box plot representing pre and post representing that these virtual labs enhances their self-efficacy to perform the experiment and enhances their self-efficacy to to understand the conceptual understanding and effectively perform the experimental procedures. So all the graph representing the same effect, while using this virtual lab, the student self-efficacy will dramatically increase comparing with our traditional classroom situation. Okay. So another one is the solar irradiance measurement system. So that paper title is Remote Trigger Dual Axis Solar Irradiance Measurement System. It is published in IEEE Transactions on Industry Application on 2020. So in this paper, we have analyzed that using the remote trigger experiment. This is called dual axis solar tracker. So we have collected feedback from the students, from the users, and we have categorized into 4 factors like easy to learn, easy to perform, user convenience, and user interactivity. So that pie chart representing that majority of the students or users are strongly agree that this platform is very easy to learn and it is very easy to perform, and also this platform is provide a user convenience, and also there's a user interactivity that enabled from the platform. So all this result representing that easy to use or easy to learn, that easiness of this platform in order to understand the certain concept from the science and engineering background. And third paper is the modification of alternate concept. So alternate concept is the concept that students will generate based on their perception or understanding. So for example, if you are throwing a ball on the surface of moon and earth, the ball will fly much higher on the surface of moon compared with earth surface, right? So students they can think like it is because of the presence of air in the air that ball cannot fly as much high as on the surface of moon. But the actual fact is it is because of the difference in gravitational pull that ball cannot fly much higher as in the moon surface. So that we call it as alternate concept, which is not significant with scientifically acceptable idea, right? So alternate concept is defined as the idea that people have which are inconsistent with scientifically acceptable idea. So if here we have identified experiments called molecular symmetry, and we analyzed how this virtual lab reduces their alternate concept in order for understanding the 3-dimensional structure of the molecules. Okay. So why we are selecting this experiment, because this required high visual and spatial thinking ability in order to understand the structure of the molecule. So usually students will have in their textbooks, they can see the 2D projection of the 3D dimension of the molecule. So some students may not be able to imagine the 3-dimensional view, and they cannot easily recognize the molecular symmetry from this type of experiments. So for that, we have used this type of molecules, planar and aromatic, non-planar and non-aromatic, etc. And the task is students have to identify the structure of the molecule based on the molecular image. Okay. So that right-hand side representing the result of this study. So this result representing the alternate concept from the particular experimentation. So that control set, as I mentioned, control set, so those students who are referring the textbook or textbooks for understanding the concept, and experimental group, those students, those who are referring the virtual lab for understanding the concept. Okay. So the control set, you can see there are that scientifically correct concept is comparatively low. That green color representing the report or response from the student, those who are correct identified that molecular symmetry, but that violet color representing those students, those who are identified the molecular symmetry is incorrect. Okay, so that means alternate concept. So if you are comparing with that experimental set, you can see that alternate concept is reduced while using this virtual lab platform, and their scientifically correct concept is dramatically higher while comparing with the control set. So which representing this virtual lab platform can also provide reduce their alternate concept, and they can create, or they will get the scientifically correct concept behind the experimentation. Yeah, so another one is the battery capacity computation. This is one of the remote trigger again. We won the best paper award in this poster category. So in this, we are providing a facility to change the temperature of the chamber, and students need to identify the discharge rate of the battery. So the battery is connected with a fan that is considered as a load with a rheostat. So the students can vary the current thrown to the load, and they can identify the discharge rate of the battery. So from this experiment, students can easily calculate the discharge rate of the battery, and they can also vary the room temperature of the battery, and they can identify what is the effect of changing temperature on the discharge rate of the battery. And another one is the cognitive load management in multimedia enhanced interactive virtual laboratories. So cognitive load representing the mental ability to solve a certain problem, or finding the solution for a problem. So if the problem is very complex, they need to use the more cognitive load, that means more thinking ability to solve the problem. So we identify how this virtual lab can reduce this cognitive load after using this platform. And we also identify how these tabs like theory, procedure, simulations, etc. are contributing to the reducing the cognitive load of the experimentation. So to identify that, we have created certain difficulty level of questionnaire. So easy, medium, and hard type of questions that we have created. So easy representing that questions involved a yes or no or objective type, and medium type questions that include that the students have to think a little bit to answer those medium type questions. And hard type of questions, they have to actually derive the equation, and they need to solve the problem in order to answer those questions. So what we have done is we asked the students to report their feedback about the questions. So students have to report whether the question is hard or easy or medium based on their knowledge. Okay. So the left-hand side, the top representing the difficulty rating of the questions by physical lab students, and left bottom, you can see the difficulty rating of the questions by the experimental set students. So if you are comparing the left, bottom, top and bottom, you can see that majority of the students from the control group, they have reported as most questions are difficult to answer. And if you are comparing with the virtual lab students' response, you can see that majority of the students reported us that questions are comparatively easy if you are comparing with that control set. Okay. And also we have another significant findings that if you are implement this virtual lab along with physical laboratory, the students' achievements means their conceptual understanding of the certain laboratories will be 100% complete if you are comparing this virtual lab with physical laboratory. Yeah. So another one is the improving perception of invisible phenomena in undergraduate physical education using ICT. So certain experiment students may not be able to see what is exactly happening inside the apparatus. For example, in this middle one, you can see the Millikan's oil drop experiment. This is one of the physical science experiment. So students may not be able to see what is happening inside this particular apparatus. So through this virtual lab platform, they can see the dissected view of the apparatus, and also they can see how these oil drops are suspending in between this in the chamber, and while applying certain voltage between the electrodes. Okay. So those kind of details students can easily understand using this platform. And also the right hand side, you can see the Doppler effect. So from this simulation, students can imagine they will get a visualization about how the sound waves are propagating through air when the source or a detector is moving correspondingly. Okay. So theoretically, they can easily derive the equations and they can find out the answer, but it is hard to imagine how this frequency change with respect to the movement of the source or a dictator. So those type of visualization we can easily provide using this platform. And also in the left hand side, you can see the Van de Graaff generator. So using this simulator, students can easily visualize how the charges are accumulating on the surface of top and what happened when the discharge is occurred in between the ground and the surface of top. So all those details students can explore using this platform, and this invisible phenomena that they will get better insight about the particular invisible phenomena that usually happen in our traditional laboratory setup. Okay. So all the results indicate that, as you can see that blue representing the classroom teaching and orange color representing the virtual lab, the students respond from the virtual lab. So all the results indicate if the students are using this platform, their visual or conceptual understanding is comparatively higher rather than using that traditional classroom situation. Okay. So just combining into 3 points. So survey-based studies indicate that virtual labs could be a supplementary tool to improve academic performance in blended environment. And current studies also indicate a trend in use of ICT-enabled virtual labs enhance academic performance of students. And it also suggests the usage of virtual lab as next generation interactive textbook for classroom users and for distance and mobile learners. All right. So with that, I'll just So this is all about. I have selected only a few papers from our publication. So if you can go to visit the publications list, you will find more interesting research findings from that list. All right. So I'll just continue with our demonstration. So as per the request from the participants, we need to cover. I will cover some of the common experiments for chemistry, biology, as well as and computer science also. So I'll just again sharing my screen. All right, so I'll just start from the beginning for So I'm just searching Amrita Virtual Lab in Google and go to the first link plab.amrita.edu for accessing this physical science virtual labs. Okay. So in this, I'll go to the chemical science. So yesterday's session, we have already explored one of the lab from physical chemistry virtual lab. So today we'll go through some other experiments, which is inorganic chemistry virtual lab, which is very common in all the UG and PG level students curriculum. Okay. So in inorganic chemistry virtual lab, that acid-base titration is the most common experiment in chemistry laboratory. So I'll just go through that experiment. So objective of the experiment is to determine the amount of substance in solution of unknown concentration using various titrametric method. Okay, so this is the objective of the experimentation. So I'll just go to the procedure. Okay. So just like our traditional lab manual, you can see what are the materials or chemicals used for this particular titration, and you can see the equations for identifying the endpoint as well as a normality of the solution. Okay. So I'll directly go to the simulator tab and also sharing the link in the chat box. All right. So you can refer to the link in the chat box for repeating the same experiment. So I'm just maximizing this view of the acid-base titration. All right. So this is the typical arrangement in our chemistry laboratory. So where you can see the left-hand side that there is a burette is available, and you can see the conical flask that placed on top of the magnetic stirrer. Yep. Right. So in the right-hand side, as I mentioned, there are several controls are available. So you can choose the titrant as well as titrate. Okay. So titrant is the solution or acid that we are using to fill in this burette, which is attached to this vertical stand over here. Okay. So we can choose the titrant from this drop-down menu. So I'm choosing hydrochloric acid as a titrant. And also there is a second slider, which is speed of titration. Okay. So next we need to choose the titrate. So the titrate is a solution that we are taking in this conical flask over here. So using this drop-down box, we can choose the titrate. So I'm choosing it as sodium hydroxide for this example. Then we can choose the normality of the titrate using the slider over here. So you can vary from 0.1 N to 2 N normality. So I'm choosing it as 0.3 N for the example. And also you can choose the volume of titrate. That means how much volume that you would like to take in this conical flask that you can decide using this slider. So the minimum quantity is 10 ml that we have fixed over here. So you can vary up to 20 ml for this titration. So I'm choosing it as 11 ml. After that, that important step, which is that we need to use one indicator to identify the end point of the titration. So when it is reaches the end point, that students can observe the color change occurred in this conical flask, that solution.
Sorry to bother. Sanish, there is someone raising hand. Nirasha,
Yeah,
do
please.
you have a clarification, please? Nirasha, do you have a clarification? Yes. Can we?
No, sir. No, sir. It's by mistake, I think.
All right, no problem. Let's continue. No problem, Nirasha. Okay.
Thank you. So
Sorry.
I'll just continue. So if you have any queries, feel free to raise the hand and interrupt in between the session. So I'll just continue with this presentation. So after setting the volume, you need to check the indicator. So the indicator is, as I mentioned, it is used to identify the endpoint of the titration. So I'm choosing it as methyl orange. So there are several indicators are available, but certain experimental selection, that means titrate and titrate, students may not be able to select all the indicators. Okay. So I'm choosing it as methyl orange for this example. And there is a start and reset button for this platform. So reset is just like a resetting the whole setup. And after selecting all the parameters, you can start the titration by click on this start button over here. So I'm just click on the start button. So you can see we are pouring this hydrochloric acid drop by drop into this conical flask. Okay. So we can vary the speed of this titration using the slider over here. Okay. So currently it is 0.1. So we are adding 0.1 ml to this big conical flask. So we can change the speed from 0.1 to 1 ml. So while changing it, the speed will increase rapidly. So we need to look carefully in order to identify the endpoint of the titration. So when it is reaches endpoint, we have to manually stop the titration and we need to identify the volume of hydrochloric acid used for reaching the endpoint. Okay. So that is the basic observation that students have to take from the traditional laboratory. Okay. So as you see that we have reached the endpoint, so you can see the yellowish, that reddish color, this conical flask solution. So that is the endpoint that students have to observe in the traditional laboratory. So when the student performing this type of experiments using the platform, they will get an idea about what are the indicators they need to use and what is the color change they are expecting at as an endpoint. Okay. So and also they'll get an approximate amount of that titrate that they need to use for getting the endpoint. Okay. So we got it as 3.3 ml of hydrochloric acid that we used to get the endpoint for this particular experimentation. And students can repeat the same experiment several times while setting all the parameters, and also they can vary the speed of the titrate and in order to get the exact endpoint for the titration. Okay. So this is how you can perform this acid-based titration from chemical science experiments. Okay. So another one is, so just go back to home page and again to chemical science. Okay. So another one is the spectrophotometry. So this, I just want to introduce this experiment because certain techniques that you need to understand to perform this spectrophotometry experimentation. Okay. So in this spectrophotometry, the objective is to measure the absorbance of a sample at different wavelength and find out the unknown concentration of the sample, and we need to verify the Beer-Lambert's law. Okay. So I'm not going to more details about the theoretical background. So directly go to the procedure tab. So you can see what are the materials required for this example, for the experimentation. So we need a spectrophotometer and we need a cuvette and blank solution. So spectrophotometer is a device that used to identify the absorption or emission of a spectrum when the electromagnetic radiation passing through the sample. Okay, so I'll just go to the simulator. Okay. So you need to log in using the provided user ID and password. Okay. Yeah. So this is the whole setup for this spectrophotometer experimentation. So this device is called spectrophotometer, where we can place the sample inside the spectrophotometer. And what will happen inside of this apparatus? It will produce different wavelength. We can change the wavelength of the electromagnetic radiation. That light or electromagnetic radiation will pass through the sample, and the detector will detect how much radiation is absorbed and how much radiation is transferred through the sample. So that is a basic principle behind the spectrophotometer. And the top side, you can see there are cuvette over here. So this beaker or this shape we call cuvette, where we are taking the sample, and we can place this cuvette inside the spectrophotometer. So we have a non-concentration, and we have unknown concentration, and we have a blank cuvette over here. Okay. And the right hand side, we can choose the solution. So suppose we are choosing it as cobalt chloride. Okay, so if we are choosing crystal violet, so for example, I'm choosing it as crystal violet, and we can change the concentration of the non-concentration. So this is the non-concentration, and we need to identify the unknown concentration with the help of this non-concentration. Okay. So we can set the non-concentration, which is 0.011 m. Okay. After that, we need to calibrate this apparatus. Okay. So for calibrating this apparatus, we can open the lid of this spectrophotometer. So there is a lid door over here. So you can click over here to open the lid. Then you need to place the blank cuvette in order to calibrate this apparatus. So there is a blank cuvette over here. You can click on the blank cuvette. So you don't need to click and drag it. It will automatically place into this chamber once you click on this blank cuvette. Okay. So certain experiment, you need to do the trial and error method to continue. So if you find difficulty, you can refer to the procedure tab. Okay. So while just click on cuvette, it will automatically place into this chamber. After that, we can close the lid by click on this over here. Okay. So after closing this lid of the spectrophotometer, we need to calibrate it. So as you can see, it is 2.316 A representing the absorption, and you can change to transmission, etc. So for example, I'm using absorption. We are identifying how much radiation is absorbed while passing through this cuvette. So we need to tear this apparatus for using this zero absorption or 100% transmission. So I'm just click on here. So as you can see, we have calibrated the apparatus. We have a 0.0 absorption for the electromagnetic radiation transfer to the cuvette. Okay. So after that, we can take out this blank cuvette, open the lid, and you can click on this blank cuvette, and it will place back to the same position. Then we need to place the non-concentration to identify the maximum absorption rate. Okay. So I'm just click on the non-concentration. So it will automatically place into the chamber. Then we can close the lid. So now there is a up and down arrow keys available. So you can change the wavelength passing through the solution. So currently it is 355 nanometer. So we can vary the wavelength using the up and down arrow key. So we need to keep on increasing the wavelength in order to identify the maximum absorption rate. Okay. So I'm just keep on increasing. So as you can see, the absorption also increasing. And after reaching a certain level, it will keep on decreasing the absorption rate. So we need to identify the maximum absorption using this apparatus. Okay. So I'm just keep on increasing that wavelength. Okay. So as you can see, when we are increasing the wavelength, that absorption is decreasing. So I'm just decreasing the wavelengths. Okay. Yeah. So the 400 nanometer is the wavelength that we will get the maximum absorption rate. So our absorption value is 0.462882. So if you are increasing the wavelength, as you can see, the absorption is also 405 is the maximum. Yeah. So 400 is maximum. So if you are increasing the wavelength, you can see the absorption is dropping down. And also if you are reducing the wavelength, the absorption value is also decreasing. So our absorption value for the wavelength 400 nanometer is the maximum absorption. It is what students have to observe from this apparatus. Okay. So I'll just repeat how typical students are performing this experiment in the traditional laboratory. So for that, I'm opening the procedure in a different tab. So just go to the procedure. So after calibrating the apparatus, we have find the maximum absorption value, and then we need to find the molar absorption coefficient using the equation over here. Okay, so I'm just repeating the same for so I'm just opening an Excel file for the calculation part. Okay. All right. So this is how typical students can easily perform this experimentation. So we need to identify the molar absorption coefficient. For example, consider E as our molar absorption coefficient. Okay. So equation for identifying the molar absorption coefficient is equal to absorption divided by concentration into length of the cuvette. Okay. So I'll come back to our simulator and maximizing the view. So as you can see, that absorption value that we can note down from our simulator 0.4682, and concentration of the unknown concentration that we have already prefixed the value using the slider over here, which is 0.011 m. Okay. Then we need to identify the length of the cuvette. So you can see the cuvette length, which is 1 centimeter. So this length of the cuvette is already fixed for each of the spectrophotometer. So you can refer to the manual of the spectrophotometer to understand the length of the cuvette. So in our example, it is 1 centimeter, and we are applying the equation over here. So I'm just applying that molar absorption coefficient, which is epsilon equal to absorption divided by concentration into length of the cuvette. So we got this constant value, molar absorption as 42.5636. Okay. So now what we have to do is we need to take out the unknown concentration from this chamber. So you can open the lid of the spectrophotometer by clicking on this position. Then you can click on this non-concentration. Then we need to place the unknown concentration. So our aim is to identify the unknown concentration for this example. So I'm just click on the unknown concentration. So it will place into this chamber. After that, we can close the lid of the spectrophotometer. Okay. So without changing any of the parameters, because we are using the crystal violet, both example, that is the 400 nanometer, it will have a maximum absorption value. So we don't need to change any of the wavelength or parameter. So we can directly note down the absorption for this unknown concentration. So I'm using the same Excel file. So I'm using it as A dash for the absorption for the unknown concentration, which is 3.6818. All right. Now we can rearrange this equation and to identify the concentration. So I'm just rearranging the equation, that is concentration equal to absorption divided by epsilon into length of the cuvette. So by rearranging this equation, we'll get the equation for identifying the concentration. So I'm just apply the same equation over here. So absorption divided by molar absorption coefficient, which is E in our example, into length of the cuvette. All right. So we get the unknown concentration as 0.0865 m. Okay. So we can, there is a privilege in this platform. There is a result section. So you can enter the value here and you can check whether our calculation is correct or not. So I'm entering the value 0.0865. Okay. After entering the value, you can click the submit button. So it will show whether your answer is correct or wrong. So if you are finding if your calculation is by mistake, if you're finding the wrong answer, so if I'm entering instead of 0.0865, I'm entering 0.0867, and if you click submit button, you can see the wrong answer. Okay, so that way students can verify whether they get the correct answer for this experiment, etc. Okay. So you can see how quickly one can perform this particular experiment using this platform. So I hope you get an overall idea about how to use this spectrophotometer from this virtual lab platform. All right. Yeah. So next we will go through some biotechnology experimentation. So I'll go to the home page and go to biotechnology and biomedical engineering. So I will use that one common experiment, which is called blood grouping. So it is available in Immunology Virtual Lab 1. So I'll share the link in the chat box. Okay. So in this immunology, this blood grouping experiment, it is one of the interesting experiment. It is good to know that interdisciplinary students also, because they will get an idea about how typically this blood grouping are of that procedure has taken care of these hospitals or any medical checkup. Okay, so here you can see how the typical procedure for doing the blood grouping experimentation. So yesterday's session I have mentioned that how to access this flash content. The same thing I'm repeating here. So I'm opening the flash EOA. So I'm giving it as an exercise after performing one demonstration. So you can watch how to access this flash content from this platform. So you can right click and open it's a new tab, this flash player EOA. Okay. So there is an alternate method for accessing the flash content. So you need to download this Windows, Macintosh, or Linux flash player into your desktop or laptop. So if you are using the Android or any other Windows mobile, you can use this link to download the one browser called Puffin browser. So Puffin browser still support flash content. Okay. So as I am using Windows system, I'm downloading this Windows flash player into my system. Yes, I have already downloaded, but I'm just replacing the same file. So after downloading it, we need to open the flash debugger. Okay, so I'll go to my downloads and open the file. Yeah. So I just request all of you to go to the same procedure. You can go to this link what I have shared in the chat box. You can download this flash debugger and open the flash player in your system. So once you are opened the flash player, you can type in the chat box continue or something. So I request all of you to go to the link and download the flash player into your system. So if you want to repeat the same procedure, please let me know in the chat box so I can repeat the same procedure. Yeah, so there is a link asked, so I'll just share the link. So that link is available in this procedure tab. You can go to the procedure, okay, and here you can see the Flash Player EOL. So you can click on the link to open this page for downloading the Flash content. So I will share the link directly into the chat box once again. So once you have downloaded this Flash Player, and if you are able to open this window, if you are able to open this window, you can type in the chat box to continue. So I can proceed with the next steps to access this blood grouping experimentation. So those who are using tablet or mobile, they can directly go to the link provided in the bottom of this page, okay, and you can install this Flash, this Puffin browser, okay, and this browser you can access this blood grouping link, and you can directly play this animation. Yeah, so because certain experiments still in Flash content, so you need to familiarize with how to access this Flash related experiment from this platform. So if you find any difficulty, please type in the chat also, so you can try to rectify the issues if you find. So if you are able to download this Flash content, and if you have successfully opened this window, please type yes in the chat box. Okay, so you can refer to the link in the chat box for downloading this Flash content, Flash player. So once you download it, you can type in the chat box yes, so that they can continue, or else if you find any difficulties, please inform that also. Yeah. So all right. Sorry. Yeah. So I'm sharing the link in the chat box. So I hope all of you can see my chat in the chat box. All right. So I can see there are some several response in the chat box. So I will wait for 1 more minute to for some other participants to able to open this Flash player. All right. Yeah. So you can see there are a lot of responses in the chat box. So I hope majority of finding how to access this, how to download this Flash player. So if you have any problem, please type in the chat box. Not able to download or not able to access. Or if I want to repeat the same, please type in the chat box also. Yes. All right. So I think which is good to go. So I'll just continue with my presentation. So I request all of you to see this demonstration. So after opening this Flash player in your desktop, you can refer to the procedure tab. Some link, share the link in the chat box again. Okay. So you can refer to the procedure tab. So in the procedure tab, there is a link we have provided. So you can copy the link starting from HTTPS up to this SWF zip file. So you can right click and copy the link. All right. So once you copy the link from this procedure, you can open the Flash player that we have already downloaded. Okay. So in this Flash player, you can go to the file, then go to open. Okay. So in this window, you need to paste the link that you have copied from the procedure tab. Okay. So I'm just right click and paste the link and then click OK button. So I will wait for 1 or 2 minute time to try the same procedure in your system. So copy the link from the procedure tab. So there is a link over here starting from HTTP. So you need to copy all this link up to this file. And you can right click and copy the link. Okay, then you can open that Flash player which you have already downloaded. And you can go to the file, then click on open link over here. And in this window, you can see there's another window will pop up. So in this window, you can paste the link and click OK to access those Flash content. All right. Yeah. Okay. So I hope all of you can able to access this Flash content. So now I just explain what is this animations and interactive animation. So this is one of the interactive animation from this platform. So you can see there's a blood grouping experiment and there's a start button. And in the right top, you can see there are several options are available. Next, start, stop, and there is a home button. And you can go to the different scenes by click on this icon over here. And there is a maximize window is available. Okay. So I'm just click on the start button. So here you can see there is a subtitle over here. Okay. So you can see take out alcohol pad from its packet. Okay. So this animation representing what are the each individual step the students how to perform in the traditional laboratory. So after taking the alcohol pad, we need to apply the alcohol pad at the site from where we are taking the blood sample. Okay. So after each step, we have to carefully deposit all the waste into a beaker. So that will also keep our laboratory clean. Okay. So after that, we need to open the lancet cover and prepare the fingertip for collecting the blood sample. Okay, so we need to prick the fingertip and fingertip with the lancet. Okay, so we are going to collect sample blood. So after that, we have to carefully deposit that lancet into the biohazardous chamber. So we need to take 3 drops of blood in a glass plate. After that, we need to place the glass slide into on the table. Then we need to cover our fingertip with cotton ball. So you can see there are each and every step is very carefully designed in this platform. Okay, so this biohazardous chambers is very important, and we need to take care of our fingertip without affecting any infections, etc. So all those details are very clearly mentioned. So now we can see it is an interactive animation. I can use my mouse pointer to move the hand over this window. Okay. So as you can see, this blood grouping experimentation, we have 3 drops of blood and we have a 3 monoclonal antigen A, B, and D. So what we are going to do, we need to mix this monoclonal anti-A, B, and D with this 3 drop of blood. Okay. So how to mix this monoclonal A? We can take this dropper, just click and drag it. Okay, so I'm just click and drag the dropper and release the mouse button on top of the first drop of blood. Okay, so we are just pouring the anti-A into first drop of blood. So we are repeating the same for pouring anti-B into the second drop of blood. Okay. Now we need to add anti-D into the third drop of blood. Okay. After that, we have to mix the blood sample with this anti-A, B, and D using a toothpick. So this is the toothpick. You can click and drag it to take the toothpick. Okay. Then we need to carefully mix each blood sample with different toothpick. So all the descriptions are provided as a subtitle. So if you find any difficulty, you can read the subtitle and perform the experimentation. So one of the important steps is if you are using one toothpick, you cannot use the same toothpick for mixing other drop of blood. So if you are using the same toothpick, there is a error message will pop up. So we need to use each individual toothpick for mixing different blood sample. So that is one of the important steps the students have to careful about in their laboratory session. Okay. So after mixing it, you can also see we need to carefully deposit into the biohazardous chamber that toothpick because it is contained blood. So it is very prone to develop or colonize bacteria or virus. Okay? So all those details are very clearly mentioned in this animation. So after mixing each 3 drop of blood using the toothpick, there is a continue button will pop up. So you can click continue to proceed with the experimentation. Okay. So now what we are observing is you can see that bloods are coagulated some part and some bloods are not coagulated. So this is what students have to observe in their observation. So they need to identify which of the samples are coagulated, which are not coagulated. Okay. So using the right hand side, there is a chart provided here to identify the blood sample. Okay. So using this right hand side chart, you can easily identify the blood sample. So for example, the first one and third one are coagulated and second one is not coagulated. So you can identify the same chart over here. So you can see it is A positive. So you can click over here to see the correct or wrong answer. So when you are clicking it, you can see the correct and you can repeat the experimentation. So every time you'll get a random sample or random result. So each student will get a different result when they are performing the same experimentation. So we are providing it as a take-home assignment for the students, and what students have to do, they need to identify the blood sample, and with this screenshot, they have to submit the report to the faculty member. So that's how we are providing it as a take-home assignments. Okay. So I have a small exercise for you. All right. So you can repeat the same experiments and you can identify the provided sample. You need to identify what is the blood group of this sample. Okay. So I request all of you to do the same experimentation and use to know how to access this interactive animation. And you can click and drag the dropper and how to drop for this anti-A, B, and D into the 3 drop of blood and how to mix it carefully. So all the steps you can try out right now. And you need to identify the sample blood group from this image provided in this slide. Okay. So please feel free to type in the chat box if you find any difficulties. So you can identify from the last color chart and you can identify what is the exact blood group from this sample. And you can type in the chat box your answer, whether it is A, B, C, D, or E. You can simply type in the chat box. So I will give you a few minutes time to practice this interactive animation. After that, we will continue with some other experimentation. All right, so I can see there are some responses are come in the chat box. So I will wait for a few minutes time to see some few other responses. All right, so I can see there are several responses coming up in the chat box, and almost everyone got the correct answer. So I'll give you 2 more minutes time to others to just try out with this interactive animation. So if you want more time, please type in the chat box also. If you require a few more minutes, so I will just allow you to perform the experiments. Yes. All right. So thank you very much, everyone. So as I can see, there are almost everyone got the correct answer. The answer is C, be positive. So I hope that interdisciplinary other faculties are also find it interested to perform this experiment from the platform. With that, okay. So thank you very much. I will continue with one more other experiment, which is from physical science. Then I will continue with some computer science as well. So thank you, everyone. So I'll go to the home page. So I'll go to the physical science. So yesterday's session, I have mentioned one electric circuit related experimentation. So I will give you a small exercise to familiarize with how to make the circuit diagram, simple circuit diagram. Okay, so using that, you can perform the experimentation. So I'm just using the Thevenin's theorem experiment from the electric circuit virtual lab. So if you go to the simulator, you cannot access. So if you are using mobile or tablet in the Pop-in browser, you can access the simulator. Or else you need to follow the same procedure that we have just followed before. So I'm just copy the link from the procedure tab. So as I already opened this Flash player, we can go to the Flash player and go to the file, open, and here you can paste the link. Then click OK button. Okay. So this is the platform for performing DC circuit simulation. So you can simply watch how to make the circuit diagram. Okay. So in the left hand side, you can see the white space for making our circuit diagram, and right hand side, you can see the apparatus or component for making the circuit. Okay. So we have a battery over here. So I'm just click and drag the battery, and there is a resistors that we can choose. Click and drag, just click and drag. That is a simple procedure for performing any of this experimentation. After that, we need to use the wire. So these are the wires. So I'm using one switch. Yeah. After that, for making this connection, you can click one end of the wire. Okay, so I'm just click one end of the wire. I'm just dragging, click and drag, and attach it to the terminal of the resistor like this. Similarly, you can connect all the terminals with wire. So I'm connecting this resistor with our positive terminal of the battery, then negative terminal of the battery with our mechanical key, and from key, I'm just closing the circuit. After that, you can watch that after clicking this white space, you can see there are show value button is available. So you can click here to see what are the current value of each of the component. So in this example, you can see the voltage is 9 volt. So you can click on the component to vary the voltage. For example, 12 volt, you can vary. And also you can change the parameters of the resistor. So you can see the 10 ohm of the resistor. Okay. So you can click on the resistor. This is called resistor, and you can enter any of the value over here. Okay. So I'm just entering 50 ohm as a resistor. Okay. So using this voltmeter, you can measure the voltage across each of the component. So I'm just measuring the voltage across the resistor 50 ohm. So I'm using this terminal of the voltmeter. You can just click and drag and place across the terminal. Okay. So as you can see that voltage drop is 0.1 volt because we have not switched on this mechanical switch. So just double click on it. Okay. So it will close the circuit. And now you can see the current is from the circuit and you can measure the voltage. So voltage drop across the resistor 50 ohm, which is 10 volt. And similarly, we can find the voltage drop across the 10 ohm resistor. That is 2 volt. Okay. So total voltage is 12 volt. That is distributed into 2 volt across the 10 ohm resistor and 10 volt across the 50 ohm resistor. Okay. So I'll just share the link in the chat box, and we have a small exercise to familiarize this circuit simulator. So you can refer to the chat box for getting this link, procedure tab. So you can copy the link and open in a flash player. After that, there is a small exercise to familiarize with this content. Okay, so this. So the question is, what is the potential difference? That means you need to identify the voltage difference, voltage across the resistor, 12.69 ohm, and you need to set the parameters as represented in this figure. Okay. So you have a two resistor, one is 10.25 ohm and another one is 12.69 ohm. And the battery, you need to use the voltage. Okay. So you need to use the voltage as 10.5 volt for this DC battery. So I have a request in the chat box. There is a because of the network issue, they're not able to follow. All right. So if you want me to repeat, please type in the chat box, repeat the experiment, so I can repeat it again. Or else we can directly continue with using the link in the chat box and open the simulator in your desktop, and you can start creating this circuit diagram and identify the voltage drop across the resistor 12.69 ohm. All right. So yeah, I'll just repeat it again. Okay. So the previous exercise, I have mentioned how to access this flash content. So I'm just repeating the same thing. So you can go to the procedure tab. There is a flash plugin EOL. You can open it in a new tab. Okay. So from the procedure, I'm just click on the flash plugin EOL. So here you need to download this flash content into your desktop using this link over here. After that, you need to open the flash player. So this is the flash player. Okay. So after opening the flash player, you can go back to refer the procedure tab, and you need to copy the link from the procedure tab. Then open the flash player. After that, you can go to the file and click open link, and you can see the pop-up box over here. And here you need to paste the link, right click and paste the link, then click OK button. Okay. So this is the way you can access any of the flash content from our platform. So after opening the flash, that DC circuit simulator, you can make the circuit diagram as represented here. So the main thing that you need to careful about, you need to make the circuit, you need to click one end of the wire and attach it to the terminal of the component. And you can observe the color change of code that represent your connection is complete. So I'll just repeat some of the. Okay. So for example, if you are making any circuit connections, you cannot place the wire on top of the terminal like this. So it is not connected when you are moving the component. Wire is still on the same place. So you have to click one end of the wire and drag it and attach it to the terminal of the component like this. So you can see the color change happen from light reddish to brown color. That represent your connection is complete. So when you are moving the component, you can see the wire is also moving along with the component. So try to make the same circuit as represented in this diagram. So if you were able to access this DC circuit simulator in the flash content, please type the chat box. Yes, so I can see that you are start doing the experimentation. So I request to the interdisciplinary So I request to other interdisciplinary faculty members also try the same exercise. So it will provide a feel about how typical students are using this platform. And what are the confusions or difficulties that students may face when they are using the platform. So all those things that you can clarify using this session. All right, so I can see one response from Jelinda. So yes. So yeah, so I request others to try also. All right, so I can see there are a lot of responses coming in the chat box, and I can see that you find it is interesting to perform this type of experimentation. So similar way, you can create any circuit for this physical science education. So you can create any circuit diagram and provide for the students group, and they will easily make circuit and they will understand the concept behind the experimentation. So that the way we can improve the students' motivation in our classroom engagement. So thank you everyone. I'll go to the other experimentation as we have a limited time. All right. So thank you very much. So next I'm going to introduce the main website. So far we have included only this Amrita Virtual Lab. So there is a main website that is vlab. So vlab.co.in, that is the main website for accessing all the virtual lab created by Ministry of Education under the project. Okay, all the 12 prominent institute. So I'm sharing the link in the chat box. Yeah, so I can see there is a one query here. There is an issue with opening the circuit diagram. Okay. So I'll just repeat the same experiment, just quick repetition. So after that, I will continue. So we need to use 2 resistors and we need 1 battery. So making it as a simple circuit. So those who are not able to perform the experimentation, you can just watch how to make the circuit diagram and take out the reading. So I'm making a simple circuit diagram. So I need to set up the value. So the first resistor, which is 10.25 ohm. So click on the first resistor, which is 10.25. So I'm just click on the blank space and click on the show value button over here. So I can see what are the values of each of the component. And second value is 12.69 ohm. So quickly enter the value 12.69. And we need to set the battery voltage as 10.5 volt. Okay. Now we need to identify the voltage drop across the resistor 12.69. For that, I'm using a voltmeter. This is multimeter. So in this example, we measuring the voltage using this multimeter. Okay. So I'm just placing the terminal across it. So as you can see, the value is 5.81. Okay. So that is answer is B. Okay. So that's way we can make the circuit diagram and verify the answer. All right. So thank you. I'll just continue with my presentation. Okay. So this is the main website, vlab.co.in. So share the link in the chat box. Okay, so you can refer to the link for accessing this main website, vlab.co.in. So you can scroll down to the bottom. You can see what are the broad areas of virtual lab. So we have engineering branches also, electronics and communication, computer science, electrical engineering, civil, mechanical, etc. So here, if you go to the chemical science, I'll just show a quick explanation, demonstration of the main website. So in the chemical science, you can see that several labs name over here: circular dichrome spectroscopy, colloid and surface chemistry lab, inorganic chemistry lab. And the right side of the lab, you can see what are the institute are created all these labs. Okay. So for example, colloid and surface chemistry labs developed by IIIT Hyderabad, and inorganic chemistry virtual lab is developed by Amartya Vishwavidyapeetham. So if you click on this link, it will redirect to our Amartya virtual lab website. Okay. Similarly, this all link will redirect to their corresponding website, and you can freely access any of these labs from this main website. Okay, so some of the labs may not be available in Amartya virtual lab. So Amartya Vishwavidyapeetham virtual lab. So you can refer to this main website, vlab.co.in. So from that you can access any of the virtual lab from this 12 prominent institute. Okay. Yeah. So if I'm using IIIT Hyderabad molecular absorption spectroscopy lab, so you can see there are links are available in the left hand side, but in Amartya virtual lab, you can see all the tabs that are available at the top side. Yeah, just keep on it. So you can refer to the left hand side, you can see all the links related to the experimentation. So you can see introduction, objective, list of experiment. So if you go to the list of experiment, you can see the lab name, experiment name over here. So under this molecular absorption spectroscopy, there are 10 experiments are available. So you can go to any of the lab, any of the experiment. So again, you can see the theory, procedure, quizzes, etc. is available, and simulation. So if you go to the simulation, you can see there are several simulations are available for this particular example. So you can see the principle of UV visible absorption spectroscopy and electronic excitation, transmission, and light absorption. So there is a link over here to go to study the principle behind this spectroscopy. So here at the bottom, you can see there are several. So you can see at the bottom, click here to view the principle of absorption spectroscopy. Okay, so you can click here to see what is absorption. So you can see there is a 3 buttons are here. So you can see the fluorescence, how the fluorescence are happening. So when you are clicking phosphorescence, you can see that will excite it and will to go to the another state. So after releasing the energy, it will come to the ground state. So this overall picturization or the schematic representation provide the idea about what is spectroscopy and what is the principle behind the experimentation, all those details that students can easily understand. So, so I'll just go to the home page. So I'll go to computer science and engineering because there are several IT and computer science faculties are here. So I'll just for them, I'll just quickly demonstrate from experiment from computer science. So I'll go to the computer science and engineering. So there are a lot of labs that are available: artificial neural network, computer architecture, organization lab, programming lab. Okay. So data structure. So those who are interested to learn other subject or other labs, you can refer to this platform. So I'll introduce one of the lab from data structure one, which is developed by IIIT Hyderabad. So just go to the link. So here you can see there are several experiments are available, concepts are available: bubble sort, merge sort, and you can see the graph, depth first search, BFS, and tree traversal. So these are all concepts related to the computer science branch especially. Okay. So for simple example, I am using this bubble sort algorithm from the list of experiment. So I'll click on the bubble sort. So here you can see the overview of the experimentation. So there is a video tutorials also available. So it will explain what are the basic principle or concept behind this bubble sort in computer science. Okay. So if you go to the bubble sort over here, you can see the aim, concept, algorithm, experiment, etc. So in our virtual lab, you see that animations, simulations, etc. But some of the labs, it is created like demo, practice, and exercise like that. Okay. So as you can see in the left hand side, instead of a simulation, you can see the demo, practice, and exercise. So you need to familiarize with this platform also. So this demo provides how the bubble sorting algorithms are applying to an array of numbers, and how this sorting happened. All those details will describe in this demo. So let's see how to access this demo. So you can see there is an array of elements of numbers we have here, and at the bottom you can see the start, reset, and pause button. And if you click to the start button, it will start comparing with each nearby elements. And if it is required swapping, it will swap. So we are swapping the array in a ascending order. Okay. So now you can see that comparing each element, and if it is required swapping, it is swapping and continue to the next nearby elements. So this is about, that is how the demonstration of the experimentation. Next is the practice. So in this practice, students can practice this swapping algorithm. So for that, you can see there is a next button, swap button is available. So students have to think whether it is required swapping in order to make it in ascending order. So as you can see, 16 and 18. So it is not required to swap. You can click the next button. Okay. So every time you can see whether your step is correct or wrong. So that pop-up will provide an overview of your procedure. So here you can see 80 or 50. So it does not require swap. You can click next button. Okay. So here also 50 or 95. You don't need to swap. Okay. So here also 95, 99, you don't need to swap. So here you can see 99 and 48. So we need to swap these two numbers. So you can click the swap button to swap. Okay. So here also you can see 99 and 80. So it is required swap. So by mistake, if you click the next button, you can see the error message, incorrect. Think again, and do we need to swap here? So that way students can verify whether their procedure is correct or wrong, and they can solve all the elements in ascending order using this bubble sort method. So that is about the practice, and a final thing is exercise. Okay. So in this exercise, there is no reverse button is available. So students have to apply the bubble sort algorithm in order to swap this array, in order to arrange array in ascending order. So okay, so for that there is a start button, next button, swap button. Okay. So once it is finished, it will at the end of the last step, it will provide our swapping algorithm is correct or not. Okay. So in this exercise, they cannot repeat the same procedure. Once they swap the element, it will swap, and at the end of the procedure only, it will show whether our procedure is correct or not. So this way, you can students can verify the basic principle about the bubble sort algorithm. Similarly, there are a lot of other labs in computer science as well as biotechnology, physics, physical science, etc. So I request all of you to can go and explore from this platform and get to know more about the experimentation. And also, I would like to introduce some other online laboratories that freely available for accessing this virtual lab. So one of the main lab is called online labs. Okay, so I'm just searching in the Google. So it is all labs. It is called online labs. So I'm just leaving this link for you. So after this workshop, you can go and explore from this laboratory, and you can see there are a lot of labs are available. So this is developed by Ministry of Electronics and Information Technology with the help of Ministry of MEITY, and also Amartya Vishwavidyapitham and CDAC Mumbai participated for developing this beautiful platform. Similarly, another one is Merlot Lab. So this is also freely available virtual labs for science and engineering curriculums. Okay, so you can scroll down to see there are a lot of labs available under biology, chemistry, physics, mathematics, okay, etc. So you can go and explore from this platform. So the method of accessing is almost similar. You can, by trial and error method, you can simply access all these labs from this platform. Okay. Yeah, so with that, I think we are almost reaching the end of the 2-day workshop sessions. I hope all of you have enjoyed the workshops. And if you have any queries, feel free to interact with me. So we have a few minutes time for interaction. And if you have any feedback also, you can share with me. So with that, I'll just thank you each and every participants, HODs and faculty members for actively engaging with this 2-day virtual lab workshop. And yes, also thanks to organizing SEMCA and Ministry of Education Sri Lanka for providing this beautiful opportunity to interact with you. So with that, I'll just concluding my 2-day workshops and hand over to Dr. Rashmi for closing session. Over to you, sir.
Thank you so very much, Mr. Sanish. I think it has been a very, very productive day, second day. I have no doubt that it went really well. Now this is time for us to conclude the session. And I'm not quite sure if there is any officials from the Ministry of Education. I'm just seeing the name of Dr. Madhura Vehala, Additional Secretary to the Ministry of Education. If she has any chance, I would wish that seeing Dr. Sadrak as well. So may I now invite Dr. Madam Vehala to make a concluding remark, if you are available with us now. Okay, if someone else has joined with her name from the ministry, some senior official from the ministry, please feel free to make a concluding note so that we can get other officials from the SEMCA also, and then finalize the sessions. This is your time.
So that's a quick announcement. I have shared one feedback link in the chat box, and also I will share the email ID for any communication also. So I request all the participants to fill up the feedback before leaving this workshop. Yeah, thank you.
Right. May I now request the director of SEMCA, Dr. Sadrak, to make a concluding remark if you are available? Yes.
Thank you, Dr. Rasmin. Thank you, Mr. Sanish and Dr. Panigradi. And thank you, Dr. Vehala, as well. Probably, she's a bit busy in other things. But from SEMCA's side, we look forward to any further advice that we may get from the Ministry of Education, CMIL, and all our partners there in Sri Lanka as to how they want to see the next phase rollout for them in Sri Lanka. So we are here to support you in your pursuits, should you think about any next course of action. We are grateful to Mr. Sanish and Professor Krishna and others at Amrita Vishwavidyapitham for their partnership in this effort in bringing to Sri Lanka the idea of virtual labs.
demonstrated online. But we only hope that this doesn't stop with the online demo. Rather, it goes to the next phase of the government thinking about a process through which they could provide a similar experience to the Sri Lankan learners. But as of now, as Mr. Sanesh would have mentioned, that anybody in Sri Lanka would want to continue to access the VLab, you can always do so. There are so many experiments you can register, and as a teacher or a student or an educator, you could still access all these for your own learning. But if we want to have something very specific to the Sri Lankan context, then we may have to think about a way to replicate how the government of India had done this. But we are here, SEMCA, not only to create awareness, but also to support you in bringing the expertise from India to Sri Lanka so that we can jumpstart it quicker rather than having to go through all the learning curve. Because the latecomer advantage is all about that somebody else has borne the birth pains, but you could perhaps easily replicate. So with those words, I once again want to thank Dr. Madhura Vehella, Dr. Hasini Talagala, Dr. Manas, Dr. Rasmi, Mr. Sanesh, Professor Krishna, and all the participants, about 150 of them still there in the group, for your continued interest in this work. And I want to thank you for your interest, but let's go forward. Thank you so much.
Thank you so very much, Dr. Sadrak. And may I also now invite Dr. Manas. I know you have been very closely working with me for the last 2-3 weeks in terms of putting this together and making it happen. It's over to you, Dr. Manas. Few words.
Thank you very much, Dr. Rashmin. I would like to just thank each and every one who participated and aspiring to continue with the practicing of this virtual lab and use this virtual lab for their teaching learning purpose. And I would like to thank Ministry of Education Sri Lanka with energizedly advocate virtual lab and giving an opportunity to all the participants and encouraging all the participants to have an exposure to virtual labs initiative in India. And I look forward to working very closely with the ministry and higher education institutions in Sri Lanka to facilitate on virtual lab in a different look and in a different level of practice, continuing with the strengthening the higher education system. Thank you very much. Thanks, Rashmin, giving me this opportunity. Thanks a lot.
Thank you. Maybe I'm taking this opportunity to make sure that we are not missing any senior officials from the Ministry of Education, Sri Lanka. Dr. Vehella, if you're there, we are so pleased to have you making a final remark. Okay, I think this is her representative. Ladies and gentlemen, and dear teachers, lecturers, and all the participants and officials from SEMCA and Mr. Sanesh. So with this wonderful concluding note from Dr. Sadrak and Dr. Manas, we are concluding the 2-day virtual session on virtual labs with the hope of meeting you all in another similar session like Dr. Manas said, but in a different format. Until then, thank you so very much for your active participation. Thanks.